Hello everyone. My name is Zhao, and I'm from Panasonic Corporation. Today, on behalf of AGL Virtualization Expert Group, I would like to talk about VirtIO, a common and standard device framework which we believe to be a key technology to achieve software-defined vehicle. First, let me give a very brief introduction about our virtualization expert group. Basically, we are interested in a lot of virtualization related topics, and nowadays our EG is focusing on applying and extending VirtIO for diverse AGL use cases. In our today's presentation, I will talk about the following three topics: why device virtualization is important for the software-defined vehicle, how VirtIO can be served as a common device virtualization framework, and what current progress and future activities of the AGL device virtualization are. So first, let me talk about some background. As shown in this picture, it is an era of change in the automotive industry that cockpit is transforming toward fully digitalized. Cockpit instruments are going to be filled with various digital instruments while being controlled by fewer ECUs, probably by only one single ECU, and the concept is called ECU consolidation. In such consolidated ECU environments, the virtualization with hypervisor technology is one of the mainstream approaches to realize this kind of a partitioning between various applications and which diverge in function safety and security. So this slide shows a general historical trending of general computer architecture. When you look at the architecture here, you can see that the physical architecture are keeping changing, but the physical system styles and also diversified even in the same architecture. However, there's always one thing that never changed. That is the importance of the software. When you're looking at the historical trend, the one mission of virtualization is that to consistently preserve the most expensive asset, that is the software, which mainly means for the application here in the case. So this is exactly the primary mission of the software-defined vehicle. So the virtualization technology include both CPU and the device virtualization as shown in the bottom picture. But when you're considering about the embedded software, especially for the automotive device virtualization, we believe is critically important, even possibly more important than the CPU virtualization. So in the automotive computing architecture, there are some specific necessities for or needs for device virtualization, especially when you're thinking about the automotive. The cars will have different grades, different models, and different devices. So such kind of a variety decided that it is a very hard component that the number, size, aspect, ratio of displays, and such kind of device will be quite different. And we need a common abstraction for such kind of diverged devices to preserve the software asset. So when considering about the centralized architecture, the same necessity is still there, because even a single centralized system still consists of multiple virtual machines. And as shown in this figure, actually it is quite logically architecture is similar to the multi-ECU system. So this example depicts the general notion of device virtualization from application point of view, which I explained in the previous slides. So in this example, the virtual display and the virtual storage are defined. The concept of the device virtualization itself is that no matter the location, the physical location of devices or the architecture of the overall system, whether it is multi-ECU or it's just have one centralized ECU with a different VMs, the device itself should be location agnostic and highly abstracted, so that the application can have a common device virtualization framework, no matter to worry about anything about the physical devices. So software-defined vehicle actually needs this kind of common device virtualization framework to isolate applications from the physical device and map the virtual to physical and dissolving the interface in between of them. So in the previous session, I have explained the necessity of the device virtualization for the software vehicle. So luckily, we take advantage of the standard and popular VirtIO as this kind of a common device virtualization framework for automotive. Our virtualization expert group did a lot of work in this part. So before that, let's look at the previous situation a little bit for the AGL virtualization in the past. You know, the para-virtual device driver layer and even part of application platform layer, such as the AGL middleware and its extension is highly dependent on the both hypervisor and SOC. This was because most of the previous solutions had the proprietary para-virtual device implementation and thus had the incompatible para-virtual devices interfaces for the upper layer software. And you imagine if you want to migrate your software from one hypervisor to another or one SOC to another, you need to do this kind of customization every time. So it was undesirable fragmentation so that OEM and Tier 1 would not have enough freedom of choice in the virtualization solutions. It is unhealthy from the ecosystem point of view. So in this situation, AGL Virt-EG actually solved these pain points by introducing the VirtIO as the standard framework for device virtualization in AGL. So VirtIO is an open source implementation of para-virtual device framework, which was very popular in the cloud servers world in the past. You know, for the automotive, it is also very important for the devices. So we introduced the VirtIO as a common interface and the implementation for the para-virtualization devices. So after this, enhanced freedom is guaranteed to choose optimal hypervisor and SOC for automotive needs without modifying upper layer software significantly. When we talk about virtualization in AGL, this is significantly important. So moreover, so beyond the hypervisor AGL or say virtualized AGL, we also consider to apply the VirtIO beyond the virtualized AGL, especially, for example, it can be utilized as a well-defined device hardware abstraction layer, even for the non-hypervisor AGL, which may further help to reduce fragmentations across the SOCs and encourage AGL-ready BSP to be ready to use. On the other hand, when we're thinking about the recent very hot topic, cloud native development, which means developing and testing in cloud and then deploying in the real hardware. So using VirtIO as a common interface between cloud-based AGL and edge AGL will further enhance the interchangeability between the cloud and native. So hence, recognizing VirtIO as a common device interface will maximize the commonality of the AGL software among SOCs, virtual environment, and non-virtual environment, and even cloud and non-cloud environment. That's not all for VirtIO. Not only limited to the single ECU architecture with the well-defined front-back architecture of VirtIO, it can also be applied to the multi-ECU use case to realize a virtualized device across different ECUs. And from the application point of view, you just take them as a whole, and you don't need to care about the detailed location and logic of the physical devices. So in general, device virtualization with VirtIO benefits in establishing a complete and healthy ecosystem for AGL to enhance interchangeability and interoperability in various scenarios, no matter it is hypervisor, non-hypervisor, cloud native, or even multi-ECU environment. So let me, after introducing all these concepts of device virtualization, let me briefly explain the current progress and the future activities of the work led by our virtualization expert group. First, regarding the VirtIO work for the hypervisor environment, we have had a very good progress. So starting from the AGL cookie COI, so VirtIO was officially supported as the common AGL device framework for virtualized AGL with basic device support. And then in the previous year, especially for Lucky Lamprey and this year, Magic Marlin, we gradually added a new support, especially for the multimedia devices. And now for most of the basic and basic use cases, including basic multimedia use cases, the VirtIO devices has already covered. So next year, this year in 2022, we will start the discussion development for more advanced multimedia features like camera control and the Bluetooth and the Vulkan support GPU, and also some automotive device specific features like CAN. Due to the time limit, I will skip this demo videos from our Virt-EG members, Linaro and Open Synergy. And if you have interested, please check the whole YouTube videos for this kind of VirtIO presentations. On the other hand, so our Virt-EG is continually developing our software on the AGL reference hardware. So the AGL reference hardware itself has the concept to use modular structure as shown in the bottom picture, where the SOC modules and the various peripheral modules can be replaced easily. So echo with the concept of the AGL reference hardware and taking advantage of the VirtIO interfaces. Now we can say that in the AGL we already achieved this kind of environment for both hardware and software, which able to support various hypervisors, SOCs, and peripherals to be chosen free by community. In the previous session, I discussed about the VirtIO for the hypervisor environment. Now we look a little bit about the VirtIO work for non-hypervisor environment. We have already done some concept level design and already started this kind of development for the non-hypervisor VirtIO from this March. We will continue the detailed design and the reference implementation and even the performance evaluation within this year. And we will share more details after we get some significant outcome for these activities. And for your reference, in these activities, we also taken other EG's requirements, especially for example, for the AVI-EG and IC-EG. So the features of the current VirtEG, like the sensitivity settings for the touchpad panels, is also taken into account. So we would like to have this interface workable for the current AGL profiles. Furthermore, we think developing and test AGL in cloud and deploy in native will greatly boost the future automotive development cycle, and cloud native is really a critical path to achieve the software-defined vehicle. So we indeed find there are some challenges around device virtualization for cloud native. For example, a streamlined cloud native development needs a standard device interface to absorb the BSP differences. Also, cloud native development for the non-hypervisor environment also needs this kind of device interface standardization. So we believe with the activities in the Virt-EG, VirtIO is the best solution to handle with this kind of challenges. So VirtIO, which was originally coming from cloud, but we extended quite a lot in automotive world. So now it's timing that we port back this kind of property to the cloud to enable such kind of seamless development between cloud and native. We are currently working with the container EG on these activities, and so we are trying to enable a container with even orchestration in the future, working on the top of VirtIO for both cloud and edge. So basically, this kind of activities is ongoing, and after we finish the development, the reference platform will be provided to community for reference. The last topic is the VirtIO work for the multi-ECU. So as introduced in the previous session, this VirtIO can be applicable to the multi-SOC or multi-ECU environment. For example, a unified virtual display based on the VirtIO GPU, which we call the Unified Edge MI technology, which proposed by Panasonic, can be established to have an integrated control of multiple displays, no matter of the system architecture. So from application point of view, one unique single virtual display device will be used based on this technology. This technology will be open sourced by Panasonic in GitHub this April. And we will also apply the Unified Edge technology to the AGL UCB and also support the Qt and Flutter so that it can be useful for all the AGL members. So we will give some demo in the AMM and in the future AOS and CES meetings. And the below diagram shows a detailed use case and the software architecture of Unified Edge MI technology, which you render the graphics from one ECU to another ECU. On the other hand, another our Virt-EG member is also working to have a VirtIO based solutions to have a common interface for the interprocessor, which means Cortex-A and Cortex-R application core and the real-time core communication, which this solution will be go to the open AMP in the future. So this slides illustrate a overall situation that how we support device virtualization in the AGL as we expand in the previous sessions. So for the VirtIO in the hypervisor environment, very good progress. Most of the basic use cases has been covered. For the non-hypervisor environment, we already started the POC activities, and we hope we can do some presentation at the end of this year. And for the cloud native environment, we started to work together with the container EG to enable a seamless development environment between cloud and edge on the top of VirtIO. And for the multi-ECU and multi-SOC VirtIO, there will be one example, especially for the GPU and display, will be open sourced in April, and we will bring this to the AGL in the later of this year. And also some ongoing development from our EG member is handling with the multi-core communication based on VirtIO. So this is all about our activities of Virt-EG, and we welcome everyone to join the Virt-EG bi-weekly call, which exactly we will have in today's session, and to discuss and contribute to define the future of automotive together with us. Thank you.